When encountering an unknown red wire during a ceiling fan installation, it is important to communicate clearly with the customer. Explain the potential consequences of not addressing the additional red wire. Discuss the possibility that it could be a ground wire, which is essential for safety. Prioritize safety by insisting on inspecting the black rubber gasket and addressing any issues with the fan's stability and humming noise. These issues could indicate electrical problems that pose a hazard. Have the customer acknowledge in writing that they are aware of the potential risks of ignoring the issues and that they are accepting those risks. Set clear expectations by informing the customer that you cannot guarantee the fan will be free of issues if they do not allow you to fully inspect and address all potential problems. Be professional by handling the situation calmly and respectfully, even if the customer is frustrated. Avoid making excuses or becoming defensive. It is important to understand what to avoid in such situations. Ignoring potential hazards by not investigating the unknown red wire or addressing the fan's problems leaves the customer vulnerable to electrical issues. Failing to communicate effectively by not explaining the importance of addressing these issues in more detail and obtaining clear instructions from the customer should be avoided. Allowing the customer to pressure you into ignoring safety concerns by prioritizing a quick installation over the customer's safety is never justified. Making assumptions that the fan's issues were minor and would not cause problems was a mistake. And not setting clear expectations by outlining the potential consequences of not addressing the issues and ensuring the customer understood those risks before proceeding should be avoided. The red wire could serve several purposes. It might be a switch like used to control the fan or light separately from a wall switch. It could also be a traveler wire in a three-way switch configuration, allowing the fan or light to be controlled from two different locations. In some cases, it could even be a hot wire from a different circuit, which would create a dangerous situation if not handled properly. Therefore, it is crucial to identify the wire's function before proceeding with the installation. Use a multimeter to check the voltage between the red wire and the neutral wire. If you read 120 volts, it indicates that the red wire is likely a hot wire. However, even if there is no voltage reading, it does not necessarily mean that the wire is safe to ignore. It could be connected to a switch that is currently turned off. The best way to identify the wire's function is to trace it back to its source. This may involve removing the cover plate from the wall switch and examining the wiring. If the red wire is connected to a switch, it is likely a switch leg or a traveler wire. If it is connected directly to a circuit breaker, it is likely a hot wire. Once you have identified the wire's function, you can determine how to handle it. If it is a switch leg or a traveler wire and the new fan does not require it, you can cap it off with a wire connector and tuck it safely inside the electrical box. However, if it is a hot wire, you will need to disconnect it from the circuit breaker and cap it off to prevent it from causing a short circuit. The black rubber gasket that the customer found could be a vibration isolator, designed to reduce noise and prevent the fan from wobbling. If the gasket is missing or damaged, it could cause the fan to vibrate and create a humming noise. It is important to install the gasket correctly to ensure that the fan operates smoothly and quietly. Check the fan's mounting bracket to make sure that it is securely attached to the ceiling joist. If the bracket is loose, it could cause the fan to wobble. Tighten the screws or bolts that hold the bracket in place. If the ceiling joist is not strong enough to support the weight of the fan, you may need to install a fan-rated electrical box that is designed to be mounted directly to the joist. The humming noise could also be caused by a faulty dimmer switch. Some dimmer switches are not compatible with certain types of ceiling fans, and they can create a humming noise when used together. Try replacing the dimmer switch with a standard on-off switch to see if that eliminates the noise. If the fan continues to wobble or make noise after you have checked all of these things, it may be necessary to replace the fan. When installing landscaping lights, it is important to follow all local electrical codes and safety regulations. Before you begin, you will need to determine the location of the lights and the type of wiring that you will need. You will also need to obtain the necessary permits from your local building department. Landscaping lights typically operate on 12 volts, which is a safe voltage for outdoor use. However, you will still need to install a transformer to step down the voltage from 120 volts to 12 volts. The transformer should be installed in a weatherproof enclosure and located in a dry, well-ventilated area. The wiring for the landscaping lights should be buried underground in a conduit to protect it from damage. The conduit should be buried at least 6 inches deep. The lights themselves should be installed according to the manufacturer's instructions. Make sure that the lights are properly grounded to prevent electric shock. When connecting the wiring, use weatherproof connectors to prevent moisture from entering the connections. This is important to ensure the long-term reliability and safety of the installation. Consider using low-voltage LED lights for landscaping. LED lights are energy efficient and have a long lifespan. This can save the customer money on their electricity bill and reduce the need for frequent bulb replacements. Use a cable locator to identify any underground utilities before digging. This will help prevent damage to gas lines, water lines, and electrical cables. Contact the local utility companies to request a utility locate. They will mark the location of any underground utilities in the area. This service is typically free of charge. Also, when the customer mentions that a professional electrician installed the same fan model without the issues they are experiencing, it's important not to dismiss their concerns. Instead, use this information to your advantage. Firstly, ask the customer for the name of the electrician who performed the other installation. Secondly, contact that electrician and explain this situation. Thirdly, inquire about their installation process and any specific steps they took to address potential issues with that particular fan model. Perhaps the other electrician is aware of a common problem with the fan or has a specific technique for ensuring proper installation. Collaborating with the other electrician could provide valuable insights and help resolve the customer's issues more effectively. If the customer is still dissatisfied with the installation, consider offering a partial refund or discount on future services. This can help to maintain a positive relationship with the customer and prevent them from filing a complaint. When documenting the customer's acceptance of risks, it is not sufficient to simply have them sign a waiver. The document should clearly outline the specific risks that the customer is accepting. For example, if the customer is refusing to allow you to investigate the unknown red wire, the document should state that the customer is aware that the wire could be a live electrical wire and that ignoring it could create a fire hazard or electrical shock hazard. The document should also state that the customer is releasing you from any liability for damages or injuries that may result from the customer's decision to ignore the potential hazards. The document should be written in plain language that the customer can easily understand. Avoid using technical jargon or legal terms that the customer may not be familiar with. Have the customer review the document carefully before signing it. Give them ample time to read and understand the contents. Offer to answer any questions they may have. Once the customer has signed the document, keep a copy for your records. This will provide you with protection in case the customer later tries to claim that you did not inform them of the risks. Consider using a digital signature platform to document the customer's acceptance of risks. Digital signatures are legally binding and can provide a more secure and efficient way to obtain customer consent. There are several digital signature platforms available, such as DocuSign and Adobe Sign. These platforms allow you to send documents to customers electronically and have them sign them using their computer or mobile device. The digital signature is then securely attached to the document, providing proof that the customer has reviewed and agreed to the terms. When setting clear expectations with the customer, it is important to be upfront about the limitations of your services. Explain that you are only able to provide a limited warranty on your work, especially if the customer is refusing to allow you to address potential problems. Be specific about what is covered by the warranty and what is not. For example, you might state that the warranty only covers defects in materials and workmanship and that it does not cover problems that are caused by the customer's negligence or misuse of the equipment. Explain that you are not responsible for any damages or injuries that may result from the customer's decision to ignore potential hazards. If the customer is not willing to accept these limitations, you may need to decline the job. It is better to lose a customer than to put yourself in a position where you could be held liable for damages or injuries. Before starting any electrical work, it is essential to perform a thorough risk assessment. This involves identifying potential hazards and taking steps to mitigate those risks. Consider the following factors when performing a risk assessment. Firstly, the age and condition of the electrical system. Secondly, the presence of any known electrical hazards. Thirdly, the type of work that will be performed. Fourthly, the qualifications and experience of the workers. Fifthly, the availability of safety equipment. Once you have identified the potential hazards, you can develop a plan to mitigate those risks. This may involve using personal protective equipment, such as gloves and safety glasses. It may also involve isolating the work area and energizing the electrical circuits. If you are not comfortable performing the electrical work yourself, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform the work safely and correctly. They will also be able to identify and address any potential hazards that you may not be aware of. When choosing an electrician, it is important to check their qualifications and experience. Make sure that they are licensed and insured. Ask for references from previous customers. Get a written estimate before the work begins. If you are working on a complex electrical project, it is a good idea to consult with an electrical engineer. An electrical engineer can help you design the electrical system and ensure that it meets all applicable codes and standards. They can also provide you with technical advice and support. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law, but it is widely adopted by state and local governments. Many jurisdictions require that all electrical work be performed in accordance with the NEC. Compliance with the NEC is essential for ensuring the safety of electrical systems. The NEC contains numerous tables and articles that provide guidance on various aspects of electrical installations. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. NEC Article 250 covers grounding and bonding requirements, which are critical for preventing electrical shock hazards. NEC Article 430 covers motor circuits and motor control equipment, providing guidelines for overcurrent protection, conductor sizing, and disconnect means. These are just a few examples of the many topics covered in the NEC. Familiarity with the NEC is essential for anyone involved in electrical work. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. These codes and regulations may vary from one jurisdiction to another. It is important to check with your local building department to determine what codes and regulations apply in your area. When performing electrical work, it is important to use the correct tools and equipment. This includes items such as wire strippers, pliers, screwdrivers, and voltage testers. Make sure that your tools are in good condition and that they are properly insulated. Use a voltage tester to verify that the power is off before working on any electrical circuits. Never work on live electrical circuits. If you are not sure how to use a particular tool or piece of equipment, consult the manufacturer's instructions or seek guidance from a qualified electrician. When selecting wire for electrical installations, it is important to choose the correct size and type of wire. The size of the wire is determined by the amount of current that it will be carrying. The type of wire is determined by the application and the environment in which it will be used. Wire sizes are typically expressed in American wire gauge, or AWG. The smaller the AWG number, the larger the wire. For example, 12 AWG wire is larger than 14 AWG wire. The ampacity of a wire is the amount of current that it can safely carry. The ampacity of a wire is determined by its size, insulation type, and ambient temperature. It is important to select a wire size that is large enough to carry the expected current load. Using a wire that is too small can cause it to overheat and potentially start a fire. There are many different types of wire available, each with its own unique properties and applications. Some common types of wire include THHN, THW, and UF. THHN wire is a general-purpose wire that is commonly used for indoor wiring. THW wire is similar to THHN wire, but it is rated for wet locations. UF wire is a direct burial wire that can be used for underground wiring. Choice of wire type will depend on the specific application and the environment in which it will be used. When connecting wires, it is important to make a secure and reliable connection. There are several different methods for connecting wires, including wire connectors, soldering, and crimping. Wire connectors, also known as wire nuts, are a common and convenient way to connect wires. They are easy to use and provide a secure connection. Soldering is a more permanent method of connecting wires. It involves melting solder onto the wires to create a strong and conductive bond. Crimping is another method of connecting wires that involves using a crimping tool to compress the wires together. The choice of connection method will depend on the application and the type of wire being used. When working with electrical circuits, it is important to understand the concepts of voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law is essential for troubleshooting electrical circuits. For example, if you know the voltage and resistance of a circuit, you can use Ohm's law to calculate the current. Or, if you know the voltage and current, you can calculate the resistance.